Getting the chainstays right is one of the trickiest parts of building a frame. Connecting the bottom bracket shell to the dropouts requires squeezing tubes or yokes between the tire, chainrings, and cranks. Over the last few frame projects, I think I've finally figured out my preferred chainstay design. It uses low mount dropouts, straight gauge 3/4 inch tubes, and a custom yoke made from 4130 plate. In this episode of the series, I'll show you how I lay everything out and then bend the yoke and chainstays to fit. The chainstay assembly is the one part of the process where I still make a full-size drawing. Being able to bend the chainstays or the yoke, then lay them on the drawing just gives me the added confidence that everything will turn out the way I want it to. I do these drawings on a piece of pre-primed MDF board. It's easy to draw on, it won't get ripped or crumpled like a piece of paper, and it provides its own flat surface. I start by drawing a couple center lines, then I draw all the main frame parts and components, so I can see the important clearances. This includes the bottom bracket shell, chain rings, crank arms, tire, disc rotor, and rear dropouts. I'm using a 73mm T47 bottom bracket shell, which measures out to 74mm before facing. I like using T47 bottom bracket shells for a few reasons, the main one being that I don't have to ovalize larger diameter down tubes to fit a smaller bottom bracket shell. I also end up with less overlap between the down tube and seat tube. I only draw the rear half of the bottom bracket shell since that's the only part that's really important here. According to my plan in BikeCAD, my chainstay length is 435, which is measured from the bottom bracket center line. I'm using a 142mm through-axle rear hub, and while I was editing this video, I realized I spaced the dropouts at 142mm. While the axle is 142mm long, the distance between the dropouts is actually 135. Of course, I realized all this after bending the chainstays and yoke, but adjusting the dropouts and disc rotor in 3.5mm shouldn't be an issue. I transferred the disc rotor measurements from a previous build. I'm pretty sure I just used a caliper on one of my production bikes to get the distance from the inner edge of the dropout to the inner edge of the disc rotor. If anyone has a source for any standard disc rotor specs, please put it in the comments. I used a tire diameter of 735mm when I designed my frame in BikeCAD, which I rounded up to a radius of 368. I base my frame designs on Surly tires whenever I can. Of any tire producer, Surly does by far the best job sharing their tire dimensions. On their website, they list the tire diameter, max width of the casing, max width at the knobs, and the radius of the tire at the max knob width. Every tire company should do this. Thanks, Surly, for doing what you do. This frame will be built around a Surly Nard 27.5 Plus tire, which should give plenty of clearance for any 27.5 tire that I want to run on this bike. I also base everything on a 49mm chain line, which is the narrowest chain line I'd use. The main reason I draw the chain line is for the chainring locations. The chainring radii are based on the chainring diameters listed on the Wolf Tooth website. Not sure why I marked a 30 tooth radius. I'll run either a 32 or 34 tooth chainring on this bike. The cranks are a bit of an estimate. Like the disc rotor, I copied the numbers from a previous build where I'm pretty sure I just took some measurements on one of my production bikes. I've seen some good crank spec sheets from companies like Raceface, but for the most part, it's been tough to find good crank specs for frame building. Again, if anyone has a good source for crank specs, please share it in the comments. I'm not sure what cranks I'll be using for this bike, but I'm basing the drawing off an old pair of Truvative stylo cranks that I have. Once I get all the clearance points set, I can bend the yoke and the chainstays to fit between the bottom bracket shell and the dropouts. I've mentioned this in other videos, but my yoke is based off the Congo Bicycle's yoke. I get the 3 pieces laser cut from 4.8mm 4130 plate, bend them in my vise, then braze them together. Here are the 3 parts before bending. Using the chainstay drawing, I mark where I think the bend should be on one side plate, then transfer those marks to the other plate. These marks are where I want to put the plates in the vise for bending. When I get the next batch of yokes cut, I'll add some more length between the bridge slot and the short end of the side plate. The current design doesn't have much material to grab onto to make the first bend, so I end up having to stick the plate out of the vise a bit further than I want. This also means I end up with a little bit of a curve at the edge of the bridge connection. It's not a big deal because I just built a fillet there, but something to change with version 2. I also want to get a thick-walled rectangular tube to use as a leverage bar for these bends. Something that will fit the yoke plate a bit tighter than the old practice seat tube that I'm using here. Like I said, this yoke has become part of my preferred solution, especially when the clearance between the tire and chain rings is too tight for pre-bent chainstays. Next is on to bending the actual chainstays. I'm using 3/4 by 0.035 inch straight gauge 4130 tubes. As I mentioned in previous videos, I had to modify my cheap tubing bender a bit. The hole that holds the end of the tube had sharp edges that would put a crease in the tube when I would bend it. I fixed this with 2 modifications. First, I enlarged and rounded the edges of the hole in the tube holder. Second, I used a small section of copper tube as a protective sleeve for the chainstay. To get the bends in the same location on both chainstays, I made a small notch on the die about where the bend starts. I line this notch up to the lines I draw on the chainstays. Just like for the yoke, I use the drawing to mark where I think the bend should go on the chainstay. Then transfer them from one chainstay to the other. There we have it, chainstays are bent along with the yoke. Once the yoke is brazed together, I'll be able to make any minor tweaks that are needed, and then cut the chainstays to length. At that point, I can braze the dropouts into the chainstays, and fit the chainstays to the yoke. All that will happen in an upcoming video. If you're interested in following along as I continue building myself a bike frame in my garage, hit the like and subscribe buttons so you'll see the new video when it comes out. If you know someone that liked this video, please share it. Thanks for watching, take care, see you next time.